Here it is. Personally, I like multiplication and division better, but I don't know that it's because this is harder. I don't know. You'll have to tell me what you think. Okay, so we're going to add and subtract rational expressions. Just as a starter, when you're adding rational expressions, so adding fractions essentially is what we're doing. What do you need to add a fraction to another fraction? A common denominator, okay? So that's huge in today's lesson. You are going to be finding common denominators, but they're not going to look like what you're used to in terms of a common denominator because there's going to be expressions in your denominator. So it's going to be binomials and monomials and all kinds of fun stuff going on. So we're going to start really basic right here just to get your brain in this mode. If I do 2/3 plus 4/5. And we said we got to find a common denominator. You're looking for what's called your least common multiple. Remember that? LCM, least common multiple. What would the least common multiple be between 3 and 5? 15. Okay, so if we want to make both of these 15, what am I multiplying the left side by? 5. Okay, but not 5. 5 over 5, right? Because we don't want to change the value of it, so we're going to multiply by 1. It's just that 1's going to look a little different. So 5 over 5 here. What do I have to multiply on the other side? 3 over 3. Okay, so this would be 10 over 15 plus 12 over 15. And then how do you add fractions? You add across only which set of numbers? The numerator, okay? Your denominator stays the same denominator. So if you can remember those rules, which, I mean, you guys have been doing that since, I don't know, when did you start doing fraction stuff? 4th grade, maybe? If you can remember the 4th grade rules, maybe it's 5th grade, you'll be in good shape, okay? But now you got to remember it with some fancier things. Okay, so we're going to step it up one little notch. Still not terribly fancy. We're going to throw a variable in. Let's say you have 6 over 5x plus 4 over 5x, and we want to simplify that. What do you get? So you would get 10 over 5x, which is actually what? 2 over x. So reduce it, right? 10 over 5 is 2 over 1. The x is still on bottom. You get that. Okay? So far, so good? Baby steps? All right, next one. This one you have x plus 5 over xy minus 3x plus 1 over xy. Okay, so this one's a little bit fancier. Notice you're subtracting. And when you subtract a binomial, what do you have to make sure you do? You gotta distribute. So you're subtracting this whole thing, which means you're subtracting this and you're subtracting that. So on top, it's going to be x minus 3x is what? Negative 2x. Okay, and then what? That was a plus 5. You can't really see my plus anymore. 5 minus 1, right, is a positive 4. So plus 4 over what? XY. Does that make sense? So make sure you take that subtraction symbol to both those numbers. Okay? Okay. So let's do a little more of what we're actually going to be doing today. We are going to factor and add with these ones. So example number 4. You have x over x squared plus 5x plus 4 plus 5x over 3x plus 3. Now, some of you on this last quiz have a tough time with factoring, with taking this x squared plus 5x plus 4 and turning it into the two binomials. If you know that is you, set up a time to sit down with me. I am happy to sit down and go over that. I wrote it on your quiz, like, come talk to me if that is you. So if you're not sure if it's you, look on your quiz and you'll see there. All right, so if we're gonna factor this, what does this factor to? So you're asking yourself, what can I multiply to get 4 that I can add to get 5? Remember, if you do star method, what can you multiply to get 4 that you can add to get 5? What would that be? 4 and 1. Okay, so this is going to be x plus 4, and x plus 1 is going to replace that one. What can you do here? Factor out a 3. So that's going to become 3 times x plus 1. Okay, so I'm going to rewrite this. On top, on the left, we have x. On bottom, we have x plus 4 times x plus 1. Okay, plus this one we have 5, and on bottom, 3 times x plus 1. Okay, do you see anything else you can factor here? Oh, it was x, sorry, 5x. Nothing else you can factor though, right? Okay, so at this point, now we need a common denominator. And here's where it gets a little bit hairy at times because there might be a bunch of stuff that you have to do in a bunch of different places, okay? Find a common denominator. Well, if I have x plus 4 and x plus 1 over here, and I have 3 and x plus 1 over here, they both already have an x plus 1. So we're going to leave that x plus 1 alone. What do you think I need to multiply this whole side by? 3, right? If I multiply this by 3, and then what do I need to multiply this whole side by? The x plus 4. So then they both have a 3, an x plus 4, and an x plus 1. So we're going to multiply by the x plus 4 over here, but keep in mind, you're not multiplying just one of them by that number. You're multiplying top and bottom by that number. So we're really multiplying by 3 over 3 here, and we're really multiplying by x plus 4 over x plus 4 on the other side, because we want to multiply by 1, okay? So that means on top we have 3x. On bottom, we're just going to leave it. We're not going to do any foiling or any of that stuff. We're just going to leave it how we see it. Plus, except for here, we're going to, the bottom you will leave be. The top, we're going to simplify this so that we can then add stuff together. So 5x times x would be what? 5x squared plus what? 20x. Okay, over 3 times x plus 1 times x plus 4. Okay, so now we have common denominators, and we can actually do, where are you coming from? 15 minutes later. Okay, tell me about it later, huh? So you have this set up, okay? We can actually start adding now. So you're just going to add your numerator. What is 3 plus 5x squared plus 20x? In standard form. 5x squared plus, and these are like terms, so we can add those together, 23x over 3 times x plus 4 times x plus 1. And that's your answer. It's kind of a lot going on there, huh? Questions on that one? Okay, let's do another. Example number 5. You have 2 over x squared minus 4x minus 12 plus 3 over 4x plus 8. Okay, what do you suppose we should do first? Got to get a common denominator by factoring. So we're going to start by factoring here. Okay, what can you multiply to get negative 12 that you can add to get negative 4? Negative 6 and positive 2. Okay, so this is going to be x minus 6 and x plus 2. Okay, so essentially what we're doing is we're taking this away, we're putting that in, right? What can you do on the second one? Factor out the 4. So you're left with x plus 2. Okay, so that gets rid of this, puts in the x plus 2 there. So I'm just going to rewrite it for organization's sake. You would now have 2 over x minus 6 times x plus 2 plus 3 over 4 times x plus 2. Okay. What's your common denominator going to be? Because that's your next step, right? Find the common denominator. 4 times x minus 6 times x plus 2. You need every one of those represented. And you don't, if you already have an x plus 2 in both, don't add another x plus 2, right? We already have that in both. So this left side, we need to multiply by 4 over 4. And the right side, we need to multiply by what? X minus 6 over x minus 6. Okay, so over here on the left, we have 4 times 2, so 8 over, by the way, if you can do some of this like in one step instead of all the steps that I'm showing you, that's totally fine. I just want to make sure I'm not losing anybody along the way anywhere. On the right side, you're taking 3 times x minus 6. You're multiplying that, so you're distributing. So that would be 3x minus 18. And then on bottom, you have the 4, the x plus 2, and the x minus 6. Okay, what's your next step? Simplify it. We're going to add that together. So all of this is getting added. 8 plus 3x minus 18 is actually what? 3x minus 10 over, and then your denominator, 4 times x minus 6 times x plus 2, okay? Anything else you can do there? You're done. It's time consuming, right? And you gotta just make sure you don't miss a silly little detail somewhere. Yeah, it's not that it's so hard to do, it's just, it's a little time consuming. Okay, how about this one? I have 3 more for you. Yep. So 3x plus y, oh, not squared, sorry, cubed. Over 3xy squared plus 5x minus 4y over x. Okay, now notice this one's a little bit different because your denominators are monomials now instead of the binomials that we've been doing. So you're not going to be factoring any of this because it's a monomial, it's not a binomial setup. So nothing to factor. What is your common denominator going to be? 3xy squared. So the left side already has the right denominator. So what do you need to multiply the right side by? 3y squared over 3y squared. Okay, but keep in mind, when you multiply this, you multiply the whole thing. So you have to distribute, okay? So it's going to be 3x plus y cubed over 3xy squared plus, and now distribute this. This would be 15 xy squared minus what? 12y cubed. Okay, over 3xy squared. And now you can add them together. So it's going to be this numerator plus this numerator, right? We're just adding that part together. We'll start with the 3x since that's at the beginning. So 3x, I would just go plus 15xy squared because that's not getting combined at all. And then these two are both y cubes. What do you get? You get what? Negative 11, so minus 11y cubed. And then all of that over 3xy squared. Okay? Questions? Okay, the last two are subtraction. And subtraction is where some just simple mistakes tend to get made because you forget that you're subtracting and have to distribute the subtraction symbol. So just be careful with this. Don't forget to distribute the minus sign. Okay. All right, so example 7. You have 6x plus 1 over x minus 5 minus 3x plus 2 over x minus 5. Anything you need to factor? No. Anything you need to do to find a common denominator? No. So both of those parts are done for you already. Now it's just a matter of subtracting. So you can think of it like 6x plus 1 minus that whole thing. So that minus is going to the 3x, and that minus is going to the 2. What do you get for your numerator then? 3x. 6x minus 3x is 3x. Minus 1. 1 minus 2, right? So minus 1, and then over x minus 5. And remember, those are binomials. You cannot say, oh, 3x over x, so that's, I don't know, people want to just call it 3 and get rid of the x's. You can't get rid of those x's. Those are factors as binomials that you got to leave be. Okay? Questions on that? All right, last one. Last one, best one, fanciest one. It's not bad. Example 8. We have 7y over 5y squared minus 125 minus 4 over 3y plus 15. So this is kind of just taking everything we've done and throwing it all together now. So we are subtracting. What would you do first? Factor out the GCF. So down here, it's going to be 5 times y squared minus 25. Okay, that would replace this. You could also do that over here. What do you factor out on the right? A 3. Okay, now what? Difference of squares. So this is actually going to be 5 times, what's difference of squares here? Y plus 5 and y minus 5. Okay, so let's rewrite the problem so we can see what we're looking at. On top, you have 7y. On bottom, you have 5 times y plus 5 times y minus 5. Okay, and then we're subtracting. On top on the right, you have 4. On bottom, you have 3 times y plus 5. What's next? Find a common denominator. What's your common denominator going to be? Right, it's going to be 15, right? Because you have the 5 and you have the 3, so we're just going to multiply those two together. And then you have the y plus 5 and the y minus 5. So we are going to multiply the whole left side by what? 3 over 3. Good. right? The 3 is the only thing missing in the denominator. So we're going to multiply by 3 over 3. So on top, you get 21y. On bottom, you get 15 times y plus 5 times y minus 5. Okay, and then we're subtracting. What do you need to multiply the right side by? 5y minus 5. Okay. So when we simplify, on bottom we know we have our 15, y plus 5, y minus 5. Okay, what do you have on top? 20 times y minus 5. Okay, we are going to distribute that because you have a 21y on the other side that we can then subtract our y's if we distribute it. So you're going to do this. This is going to be 20y minus 100. Do you mind if I just erase the red one there and write in the 20y minus 100 so I don't have to write the whole thing again? Is that okay? Okay. So we're going to take this out and put in 20y minus 100. Now what? How do you simplify that? Right, that minus sign has to go to both of these. So it's going to be 21y minus 20y, which is what? Y. And then what? Here's where plus 100. It's minus a negative 100. Minus a negative is always plus a positive. So plus 100 over 15 times y plus 5 times y minus 5. Whew. It's a good one, huh? Any questions on that?